So in this video we look at language translators. It's 5.2 of the CIE 9618 specification for A-level computer science, but does apply obviously to other exam boards. And this is part of a series of videos for the CIE 9618 A-level course. So there are three main types of translators, but they all convert code from one format to another. So the word translator is an umbrella term that covers all three types. And the types are assemblers, compilers, and interpreters. Assemblers convert assembly language to machine code. This is a relatively simple process since there's already a one-to-one relationship between assembly language mnemonics and the machine code instructions that are needed. You can have one or two pass assemblers, with a two-pass assembler being able to resolve forward references. Compilers take programs that are in high-level code and convert them into machine code. They look at the entire program and create a file containing machine code. The machine code file, sometimes called an executable or exe file. Compilation is a complex multi-stage process, and compilers can optimize code. An interpreter is said to convert high-level code into machine code one line at a time, although it's not actually literally one line. That's what's normally said, and it's an easy way of framing it. In other words, it doesn't convert the whole program into machine code. It just converts part of it, executes that, and then converts the next part, and so on. Interpreters do not produce a complete executable file. Just a note about machine code. Different CPUs, different computers will use different architectures and have different instruction sets. And each instruction may have different numbers to other instruction sets. That means that translators need to produce the specific machine code for whichever instruction set the intended device uses. This is sometimes referred to as a platform. So a program assembled compiled for one instruction set will not work on another instruction set. It's platform dependent. Now it's possible to have a hybrid where we're doing partial compilation and partial interpreting. An intermediate stage is produced, for example, bytecode. And bytecode is platform independent set of instructions. The bytecode then needs to be interpreted at runtime by a virtual machine. So first we compile into bytecode, so it looks at the entire program, creates a single bytecode file for the entire program, but that still needs to be interpreted at runtime. Obviously it's a simpler job to interpret that bytecode because some of the work has already been done. So why use the hybrid approach? Well, the benefits are it's portable. The bytecode isn't tied to a specific platform. You can run it on any machine so long as it has the interpreter on it. It's faster than pure interpretation. So the bytecode that's being produced is much closer to machine code. There's less work for the interpreter to do, so it will run quicker. However, the execution is slower than pure compilation because you still need to do interpreting at the end. And another good benefit for this is security or sandboxing. The actual virtual machine that does the interpreting can control what bytecode's allowed to do. So it won't allow anything to happen. It will do some checks before actually running the bytecode. Benefits of using a compiler are mainly the faster execution. The program has been completely translated to machine code. No more translation needs to happen on the machine after that. So it can run directly on the machine, and that's fast. You can also use this to protect source code because you're just distributing a compiled executable file rather than the original source code, then people don't get to see how you wrote the program, and it's much more difficult for them to copy it or make changes to the code. It also means that you find your errors up front. The compiler will look at the entire program and find all the errors and report them rather than just the first one. So you can get to see what all the errors are and how many errors there are. And you don't need any kind of software translator at runtime. You don't need a compiler or anything to run the program. It will run natively on the machine. The drawbacks of using a compiler, though, are it does slow the development testing cycle. Every single change you make to your code requires a full recompilation before you can test it again. And for large programs, that can be quite tedious. The output, obviously, from a compiler is platform dependent. So the executor was compiled for a specific processor or operating system, and it wouldn't run on a different platform without recompiling. Compiled code is harder to debug interactively. You can't do it line by line. You've just got to do the whole thing. So compilers are best suited for things like commercial software that's being distributed en masse. So a video game or word processor sold to the public. And that's because speed matters. So the execution, especially of things like games, needs to be as fast as possible. You want to protect your source code because this is commercial software. You only want to write it once, and you're going to run it millions of times. So the compile costs are not a problem compared to the execution costs of other methods. Interpreter has benefits though. So the benefits of interpreter, the immediate execution and testing of code. You can start straight away by testing your code. You can run it. If there's a bug in the first line, you find it immediately. You don't have to waste time waiting for the whole thing to be compiled. It's easier to debug because execution stops at the exact line where the error occurred. So it's easier to pinpoint mistakes. If you compiled and get a list of errors at the end, then you have to go back and find, the point at which each one occurred. Whereas with interpreting, it's obvious. That's the line. You just got to that line and it doesn't work. Interpreter also gives you platform independence because your code can run on any machine so long as it has an interpreter installed. Drawbacks of interpreting are slower execution. You have to translate the code every single time. No matter how many times you've run it before, you've still got to translate it. And that can be significant because some code is going to be done in many, many times and it has to be translated every single time. You do tend to give the source code away with this method, so people get the source code that needs to be interpreted. So you can't keep it private. It's not so good for commercial proprietary software. And every machine that wants to run this has to have an interpreter installed, whereas if it's compiled, they don't need anything else. So where would you use interpreters? Use it where code changes frequently. For example, students learning to code, they're going to be making quite a few mistakes in code and need to change it and run it again, change it, run again, and so on. If you're just debugging new scripts, so brand new code, you can use this. Because the ability to test and fix code line by line speeds up that write, test, fix cycle that you go around quite often in the early stages of developing software. So an integrated development environment is a piece of software. It's a tool that combines or integrates many different functions into a single place instead of having many different programs to do that. So they bring all these tools together in one place to make it really easy and convenient to develop software. There's lots of different IDEs. Some you may have used already. There's Visual Studio, which supports multiple languages. PyCharm, which is focused on Python, Idle, the built-in but very basic IDE for Python, NetBeans for Java, as Android Studio and Xcode, and these are for mobile development like Android and Apple development. So some of the features that you can bring into an IDE include context-sensitive prompts, dynamic syntax checks, pretty print, the ability to expand and collapse code blocks, single stepping through code, setting breakpoints in code, and report windows. And there's others as well. This is not an exhaustive list of all the features you might find. So they help with different aspects of the software development. For example, coding is helped by things like context-sensitive prompts and autocomplete. The initial error detection can be helped by dynamic syntax checking. General presentation is helped by things like pretty print and expanding collapsing code blocks. And debugging is helped by single stepping, breakpoints, variable watching, and report window. So let's have a look at some of these context-sensitive prompts. Autocomplete. As the programmer types, the IDE displays a list of suggested keywords, variable names, function names, method calls, and so on, that it thinks are relevant to the current context. This speeds up coding and reduces typing errors because the programmer can select from the list rather than typing the full name and perhaps getting typos. Other things that help are auto indentation, so it automatically indents new lines. For example, when you're doing Python and you type a colon in and enter, it'll automatically go to the next line and indent for you. And that helps to keep code readable, and of course in Python's case it's for the syntax as well. Autocorrect automatically corrects some of the mistakes you make. Obvious things like forgetting to put an end quote or an end bracket on something. It can work that out quite easily and just fix it for you without even asking. Then we've got dynamic syntax checks. So the IDE can check your syntax as it's being typed rather than waiting until you want to run it or compile it. So the errors are flagged in real time, possibly with a wavy underline, sometimes red, beneath the code that it thinks is wrong. And this allows the programmer to fix mistakes sooner rather than having to look through the list of errors later. You've also got syntax highlighting. So you can highlight different kinds of things in the code, like keywords, variables, and strings, and so on, so that the programmer can notice more easily when they've done something wrong. So for example, if you forget to close a string off with a quote, it wouldn't change color as you expected it to. So that can just flag to you that something's going wrong, and then you go, oh yeah, I forgot to put the quote in, and then it will change the color correctly. In terms of presentation, to make it look better or easy to understand, Pretty Print automatically formats code according to a style convention or set of style conventions. For example, consistent indentation, color coding the keywords, and spacing, use of white space, and so on. So this makes code easier to read, which can help you debug, because if you can understand a program more easily, you're more likely to be able to find the bugs in it. You can also expand and collapse code blocks, and that helps because you can hide some of the detail in a program. It could be very big, very complex, and then to focus and to allow you to narrow down to a particular problem, you might want to hide some of that code, and that's what collapsing code blocks does. So for debugging, we can use something called single stepping. So this allows us to execute the program one line at a time, and it pauses after each line and waits for us, the human, to say whether we're ready for it to move on to the next. And then obviously we're watching what's happening while we're doing that to see if something's going wrong. So we could be looking at variables, for example, or seeing which line of code is being executed. And if it's not what we expect, then we know that something's gone wrong at that point. Similarly, you can set breakpoints, which will allow the code to run up to a particular point. You can skip code that you know works and just get to the point where you think that it's going wrong, and then see what happens. And for debugging, again, you've got a variables window, and a variables window would just display all the variables that are in scope at the point where execution is paused. So if you've set a breakpoint, for example, or you're single stepping, then the variables window will show the variables that are relevant to that code at the time. The expressions watch window allows you, the programmer, to enter a specific variable or expression that you want to monitor. So you can keep that being displayed throughout the code execution. That's useful for tracking one particular value of interest without being distracted by everything else. And you've also got a report window that displays the error codes, the exception messages that are generated during execution. This will give you descriptions of the type of error, the line number it occurred on, and this helps the program obviously locate and diagnose the problems that are happening. And that's the end of 5.2. So next time we'd be looking at 6.1, which is data security.